Hello, my dear students. How's going? Look, we are just beginning the chapter number 23, that's about alcohols and carboxylic acids. And today, video lesson, we'll just talk about the introduction of alcohols and the properties, the physical properties and the chemical properties. And two chemical reactions will come under discussion: oxidation and combustion. So let us begin with the introduction. Okay, have you ever seen these pictures before? You see the alcohols and the cones are used to produce fuels, and isopropyl alcohol used as antiseptic, and you see the solvents, they are mostly alcohols. So we are going to study about some very demanded and useful class of compounds and why they are called and classified as alcohols. Let's find their structure. So alcohols are in fact organic compounds that carries at least one hydroxyl group, that's the functional group, bonded to a saturated carbon atom. So we see normally they are defined as a saturated carbon bonded to the functional group OH, that's the hydroxyl group. So we see a saturated carbon means some aliphatic carbon, and so aliphatic organic compounds with hydroxyl group as a functional group are called as alcohol. So it's not a single compound, it's a class of compound, it's a group of compounds containing the same functional group. So this is how the general formula is ROH, where the R is representing the alkyl group, which comes from the alkane, and this OH group is in fact the functional group of alcohols. Similarly, a carboxylic acid is an organic compound that contains a carboxyl group in it. Now, carboxyl group is the combination of two functional groups. You see carbonyl groups, that's the functional group of aldehyde and ketones, and hydroxyl group, that's the functional group of alcohols. So carboxylic group means carbonyl carbon is bonded to hydroxyl group. So this is how they are generally represented by RCOOH or RCO2H, and this time the R refers to any alkyl group, means saturated carbon, alkenyl group or unsaturated carbon with a double bond in it, or aryl group means with a benzene ring C6H5 in it. But generally, if we talk about carboxylic acids, then again we need to focus on this functional group, because you know that functional group becomes the reason for all the chemistry or the reactions or the properties for any organic compound. Now we proceed to understand how they can be drawn. You see, the alcohols consist of carbon, hydrogen and oxygen, and how they are structured. Now we have a saturated carbon, means a tetravalent carbon with 4 valencies in the compound. Okay, so they are represented by R, which represents the saturated carbon group. A bivalent oxygen is present in the compound and its 2 valencies, one is satisfied by carbon and the other side it is bonded to hydrogen. So this OH becomes the functional group and the R is the alkyl group. Okay, now one carbon alcohol is CH3OH, that's methyl alcohol, and you see the tetravalency of carbon is established and this OH group is the functional group. Again, the next member of the alcohol family is ethyl alcohol, the molecular formula C2H5OH. Again, you will be seeing and observing the tetravalency of this saturated carbon with the same functional group in it, hydroxyl. Now we come to discuss naming. You know, like other organic compounds families, alcohols can be named both ways, common names and IUPAC names. And common names means the name which is non-systematic. Now, how common names will be written? You have to write the name of the alkyl group, then the whole word alcohol. So you see, if you have just one carbon in the alcohol structure, then its common name is methyl. The name of the alkyl is methyl, the whole word alcohol. So name will be methyl alcohol. And if your alcohol has two carbons in it, the name of the alkyl will be ethyl. So name goes ethyl alcohol. If you have three carbons in the alcohol structure, the alkyl is propyl, the word alcohol. And you see, when this OH group is not attached on the cornermost carbon or the terminal carbon, then you can also talk in terms of its position. Like in this case, methyl group, this OH group is attached to a propyl carbon, means like this OH group is attached on the secondary carbon. So here you can see the OH is attached on the secondary carbon. So the name can go isopropyl or secondary propyl alcohol. Like in the same case, when this hydroxyl group is attached to a 4-carbon chain, but this hydroxyl group is attached to a secondary carbon, to a secondary position, then your alkyl will be named as secondary butyl alcohol. But when we write the IUPAC name, we have to follow certain rules and regulations. And in writing so, we replace the last E of alkane by this OL. So the name will become alkanol. Suppose if you have one carbon in the structure, then your name will be written from methane. So removing the last E from methane and adding OL, the name goes methanol. For 2-carbon alcohol, the name will be ethanol. For 3-carbon alcohol, the name will be propanol. You can write the position before the name as well. So it will be 1-propanol and so on. To practice nomenclature and naming of alcohol, you need more practice. Now we further proceed to discuss properties of alcohol. Now first we'll talk about the physical properties. Alcohols are volatile liquids at room temperature. Volatile liquids means they are easily vaporized, and they're liquids at room temperature because they have got a very low boiling point as compared to water. That's why their volatility is very high. And as you see, when we see the boiling points across the series, we find a regular increasing trend of boiling point. Why this is so? Because when we go for higher member alcohol, we see the increase of carbon atom becomes the reason for a gradual increase in the boiling point. And the second very important point is that alcohols are miscible, or they are mixed with water in all proportions. So this is simple, very simple to accept that alcohols just similar to water because they are polar solvents. Now we'll discuss the chemical properties. First we discuss the combustion reaction. As I explained you twice or thrice, that a combustion is a chemical reaction in which a substance burns with oxygen to give carbon dioxide water vapor. And the main interest or the glamour of this reaction is that it produces heat or energy. So what is the main interest to bring this reaction about, that combustion always produces energy or heat, and we use this heat. So that is why alcohols are also used as a fuel. And this is a safe fuel which produces no harmful waste, just like petroleum products. Now we write the chemical reaction here. Alcohols, which are generally represented by ROH, a molecular oxygen is involved in this reaction and produces carbon dioxide and water or water vapor, because very high heat is there. So this reaction is very useful. And if I ask you to write the combustion reaction for ethanol, you will be just writing the example of alcohol reacting with oxygen to produce carbon dioxide and water. Now just have one more look to balance this reaction by putting 3 oxygen and 2 carbon dioxide and 3 molecules or moles of water. So this reaction specifically discusses the combustion of ethyl alcohol or ethanol. And look, they are used as a very demanded fuel. And another use, that alcohol is also burned on fruit cakes to give them a yummy and attractive look and taste as well. The next reaction is oxidation. Now we have to compare this reaction with combustion. As in the previous case, combustion involves the reaction of molecular oxygen which produced carbon dioxide and water, and one more thing, yes, that is energy or heat energy. Okay, so this is the condition for combustion. Now we are going to study another reaction in which oxygen is taking part and it's converting alcohol to another class of organic compound, that is carboxylic acid, and water is the byproduct. You see here oxygen is in its atomic form, nascent form, because this oxygen is coming from an oxidizing agent. Yes, that's the main clue for this reaction. So this reaction is called as oxidation, and normally the oxidizing agent which is used for this reaction is acidified potassium manganate, KMnO4. So when this reaction proceeds, we get carboxylic acid and water. Now we'll practice equation for ethyl alcohols oxidation. Suppose we have C2H5OH alcohol, and this oxygen is coming from KMnO4, and the product is CH3COOH, that's ethanoic acid, and water is the byproduct. So here you see the conversion of alcohol is taking place to another class of organic compounds, that is carboxylic acid. So whenever during some chemical change the alcoholic functional group is converting into carboxylic functional group, we say oxidation is going on. And these kinds of questions are coming in your multiple choice questions and your theory section also. So always get command for these oxidation types of reaction during organic compounds where one functional group is converting into another functional group. Now when we come to discuss its application, you see it is very much useful to us, because in Singapore the police is using breathalyzers, the instruments or gadgets, to test the amount of alcohol consumed by drivers. This instrument which is called as breathalyzer, it contains an oxidizing agent. And if a breath of a driver contains a high level of alcohol, the color change is quickly registered on the device, and this is how it is used. Now I have explained the topic, I have tried to explain it well. Now this is your turn to test your understanding about the topic and try solving test yourself exercise 23.1 and 23.2, and wait for my next lecture in which I will be explaining you a very important topic that's about production of ethanol. See you and very take care. Goodbye.